Hello everyone. In this video, we would like to discuss previous year questions, that is from power electronics subject. These questions were given in TSSPDCL 2023 examination. Now, first question, there are some statements are given. Choose the wrong statements from the following on three-phase full converter where top switches are numbered 1, 3, 5 odd numbers and bottom switches are numbered 4, 6, 2. 1 plus 3 is equal to 4, 3 plus 3 is equal to 6, 5 plus 3 is equal to 8, but total there are 6 devices, hence 8 minus 6 will give you 2. Now just for quick reference, I will also show you the circuit diagram for this three-phase full converter. So in this upper half devices T1, T3, T5, or it is simply mentioned as 1, 3, 5. Lower half devices 4, 6 and 2 from left to right. Now this is a standard notation. There is nothing twist is given in this question. Now what we have to observe, what is the wrong statement from this? Now before looking into the statements, the basic idea is in any vertical switch, say for example if T1 is on, T4 should not be conduct. Suppose if both the switches conduct simultaneously, then what happens? It will short circuit. Of course in this rectifier circuits there is no problem because the load will have lot of high inductance, therefore it will create freewheeling action. And in the same question, if it is given in the inverter's perspective, as the source will be voltage source, it will get short circuit, so it should not be conduct together. So here also in this case when upper half device is conducting, lower half device should not conduct. Similarly, so that is the same statement, option A, even S1 conducts, S4 should not conduct, that is correct. Similarly, S6 is conducting, S3 should not conduct. So the point is any two devices simultaneously will not conduct in one vertical arrangement. When S2 is conducting, S5 should not conduct, so that is also correct. So when S3 conducting, S4 should not conduct, so this is a wrong statement. Therefore for this question, answer should be option D. Now let us move to the next question. This question is basically from PWM concept in the inverters chapter. Each of 5 equal pulse widths in every half cycle of single phase inverter is pi by 5 radian. If the input DC voltage is 100 volt, what is the RMS value of the output voltage? Now first let us note down what is the data given. Source voltage is given as 100 volt and the number of pulses are given as 5. Each pulse width notation is 2D by N. This is given as pi by 15 radian. This is a concept from multiple pulse width modulation in the inverter circuits. Therefore, what is the formula for RMS output voltage? VDC multiplied with square root of N into 2D by N, N into each pulse width divided by pi. So VDC is 100, number of pulses per half cycle is 5, each pulse width is pi by 15 divided by pi. Therefore pi cancel and 5 into pi by 5 will give you pi by 1 by 3. So 100 multiplied with 1 by root 3. So 1 by root 3 value is 0.577 and hence the answer for this question will be 57.7 volt. Option A is the correct answer. Now just before the exam, I will suggest in the overall electrical engineering there are some standard numbers. Whoever attended my class, they will be familiar. something like 1 by root 2, 1 by root 3 value, root 2, okay, 5 by root, so 1 by root 2, 1 by root 3, next root of 2 by 3. So these type of number patterns just before the exam, try to revise. It will give you very fast calculations, okay. Even in the exam where calculator is not allowed, in those exams also data will be framed to have these type of cancellations. Now let us move to the next question. So this is an interesting question. A three-phase semi-converter is operated with a firing angle of 30 degree. So what is given here? Circuit is three-phase semi-converter. Alpha is given as 30 degree. What is the input displacement factor? Input displacement factor means you have to find out dpf. So what is a dpf? That is cos alpha by 2. Okay, so alpha is given, therefore cos alpha is equal to cos 30, that will give you root 3 by 2. Now just based on simple trigonometric formulas, we know that 1 plus cos alpha is equal to 2 into cos square alpha by 2. Therefore I can write down here 2 into cos square alpha by 2 is equal to 1 plus root 3 by 2. That is nothing but 2 plus root 3 divided by 2. Therefore cos square alpha by 2 is equal to 2 plus root 3 divided by 4, because the 2 will come in the denominator. Now you can find cos alpha by 2 is equal to total root of this, root of 2 plus root 3 divided by 2. Root of 2 plus root 3 divided by 2. So option A is matching. So this is a very nice question framed. Only thing you need to remember is what is the displacement power factor. So now my sincere suggestion before exam, 1 month or 45 days before the exam time, suppose when you are practicing this type of PYQs, now in this question it is given that three-phase semi-converter alpha given and what is the displacement power factor. So you should revise what are all the related formulas in this particular circuit. Say for example, three-phase semi-converter is given. Now in the upcoming exam you may expect what is a displacement power factor for single phase semi-converter, or in three-phase semi-converter dpf is given, so what is the input power factor formula. So like that you question yourself. Okay, so by the time 1 month before the exam means you should have all your short notes readily available. You just revise in your mind, take a calm mind, and you just revise. Wherever you struck, you just refer your notes and then you can revise it. Okay, suppose three-phase semi-converter is given. If a same question is given from single-phase full converter, single-phase semi-converter, three-phase full converter, three-phase semi-converter, what is DPF formula, what is IPF formula, what is total harmonic distortion. So like that, if you revise it, so it will be quick revision. Okay, of course during this preparation time you may feel it will take some time, but it will really give you quick recollection. Remember, the most you use your brain just to recollect the concepts, your brain will work that much sharply. Okay, if you sit idly and do nothing, then you will not be able to recollect it. So people used to say that I have less memory, but I will not agree that the more and more you use your brain, your memory power will increase. Let us move to the next question. The input power factor and displacement factor of an AC to DC converter are measured as 0.8 and 1.0 respectively. So now this is another in a similar line question only, same paper, similar line. What is given? Input power factor is given, IPF is equal to 0.8, and what is also given? Displacement power factor, DPF, is given as 1.0, right? So we know the relationship between IPF and DPF. IPF is equal to distortion factor multiplied with displacement power factor. Therefore, what is a distortion factor here? 0.8 divided by 1. Now keep it like that. So from the given data, quickly I calculated what is the distortion factor. Now what is the question here? What is input harmonic distortion? By seeing the options, it is asking in percentage. Now what is the formula between total harmonic? See, input harmonic distortion is simply nothing but total harmonic distortion. What is the relationship between total harmonic distortion and distortion factor? THD is equal to 1 by df whole square minus 1. Therefore, you have to calculate this value, root of 1 by 0.8 whole square minus 1. In terms of percentage, it will give you 75%. If you multiply with 100, you will get in percentage. Okay. So the numerical value will be 0.75 and hence it will give you 75% as the correct answer. Now let us look into another question. This question is based on the DC to DC converters chapter. If F is the switching frequency and alpha is duty ratio, then ripple voltage across capacitor in buck boost converter. Now when this type of questions are given, it is data is not given in a proper way, but what is now if you recollect from our notes, delta V naught, okay, peak to peak ripple is equal to delta V naught is equal to delta Q divided by C. What is the formula for this? I naught multiplied with D into T divided by C, or you can also say that I naught by C multiplied with duty cycle ratio divided by switching frequency. So I will be happy if the question is given is proportional to, that is the appropriate wording. Of course it is not given in the question. Okay, anyhow, just based on the options you can say that D by F or alpha by F. So you can select option D as the more appropriate answer. Now whenever any so this type of mismatch is given in the question, you don't struck in the examination hall, do not struck. Of course it should be is proportional to, question should be given like that. If you really, it is a big concern, you can challenge the question later, but in the examination hall don't stuck with that and don't try to fight with the question also. So from the given options, what is a more appropriate option, you can answer it. Okay, if a key is given in a completely differently, then you can challenge that fight you can do after examination hall, but not in the exam. You do not struck with that. Of course if you are not able to take any decision, what is the best option, you just move on to the next problem. Okay, and once all are completed, then in the revision time in the examination hall also you can see. But from, in my opinion, based on all the options, option D will be more appropriate answer. Now let us look into another question. It is a very simple theoretical question. If IC, VGE, V and VCE represent collector current, gate to emitter voltage and collector to emitter voltage respectively of an IGBT, then the transfer characteristics is the plot of. So transfer characteristics, first you should understand that transfer characteristics means output voltage versus input voltage. In this particular power semiconductor devices, that could be control voltage. Now if you just able to draw IGBT switch symbol, then you can answer this question. So this is a collector, emitter and gate terminals. Okay, so this is a IGBT symbol. Now in this output current, you can also say that current flowing through the switch, and control voltage VGE. Therefore you will have the characteristics something like this: output current IC on y axis, VGE on x axis. So IC on y axis versus VGE on x axis. So option D will match with this question. Now suppose if this is the question given in the previous exam, suppose if the examiner want to extend the same question in the next upcoming exam, Now in the four options, four diagrams can be given. Find out what is the correct option from that. What is the output characteristics? IGBT is given in this previous year exam. In the next coming exam, you may have a MOSFET characteristics. Okay, so like this, you can frame, you can increase your circle of preparation. Okay, you can increase your circle of competency, so that if any one particular concept is given in the previous year exam, what could be expected question. So do not depend on the previous year questions. Exactly same question will repeat in the exam. If that is same question repeats, then everyone will success, right? But the point is, if this is the question in the given in the previous exam, what could be an expected question, a similar model, right? So difficulty level will be almost the same if it is repeated, and what could be an option, under what condition IGBT will act as a switch, and under what condition MOSFET will act as a switch, what is the voltage control switch, what is the current control switch. So like this, you can increase your circle of competency. Now let us look into another one. This is from Chopper's chapter. In chopper fed DC drives, choose the correct combination of quadrants. So just by at a glance, I can understand it is given from type C and type D choppers. Okay, so if you are able to recollect the circuit diagrams for type C and type D choppers, then you can easily answer this question. So just for your quick understanding, I have shown here circuit diagram for type C. This is a type C, and type D chopper. Okay, so this is a type D circuit, right? So now this is a type C chopper, and this is type D chopper. So basically V0 on y axis, I0 on x axis. Now in case of type C chopper, we will have quadrant diagrams like this. So this is for type C chopper. Okay, now coming to type D chopper, I0, and this is a V0, and you will have quadrants of operations, first and fourth quadrants. So this is the basic concepts discussed in the class. Suppose whenever you get a doubt, if you recollect the circuit diagram, then you can easily answer this. Say for example, in this chopper, this is the direction of the load current when CH1 and CH2 are on. Suppose if these diodes are on, this is the direction of the current. So under any condition, current is always positive. It is always in one direction only. Okay, and the voltage can be positive or negative. Therefore, it will give you first and fourth quadrants. Okay, so accordingly you can choose it. Type D chopper operates in quadrants 1 and 4. So we can say that option C is the correct answer. Okay, so you can frame. Now in this case, type C and type D is given in the options, or sometimes you can also get a question, circuit diagrams, 4 diagrams will be given, and what is a identify type A, type B, type C, like that, or else different circuit diagram names left side, quadrants in the right side, or match the following type. So you just revise these type of concepts in the notes. Let us move to the next question. Now this is a very interesting problem. Even I have not seen this type of model even in the GATE exam also. This is just a little bit beyond AE exam, I can say. Now see that, identify one of the angles at which the average DC voltage equals to instantaneous output voltage of single phase full wave rectifier. Now here also students are worrying that single phase full wave rectifier means, is it a full converter, semi converter, alpha not given, diode circuit? So these type of doubts. So let us have a generalized expression. Now nothing is mentioned. Just by seeing the output voltage waveform, I can clearly say that it could be diode output, but alpha is mentioned. So I can say that diode output with alpha 0. You can also say that full converter means. So what I can say, first let us write down equation for V naught when alpha is equal to 0, that is 2Vm by pi. And you can also say that single phase full converter is operating in such a way that firing angle is maintaining in such a way that V naught DC voltage is equal to instantaneous value of the output voltage, Vm sin omega t. Therefore, you can cancel Vm on both sides, then you will have omega t is equal to sin inverse 2 by pi. Sin inverse 2 by pi. Now, say for example, if I say that this is point x, y, z and w. Now, at point x, you can say alpha is equal to sin inverse 2 by pi. At point y, what could be the angle here? Alpha will be equal to pi minus sin inverse 2 by pi. In all these points, DC voltage is equal to instantaneous value of the sinusoidal function. At point z, how to define alpha? That will be pi plus sin inverse 2 by pi. At point w, alpha can be defined as 2 pi minus sin inverse 2 by pi. So these are the points. Now look into the options. So any one option can be possible. Okay, pi by 2 plus sin inverse 2 by pi, rejected. Pi by 2 minus, that is also rejected. This is also rejected. So pi plus sin inverse 2 by pi. So this option can be matching, right? So these are the questions given in the last year of exam TSSPDCL 2023. Now with more PYQs I will upload in our YouTube channel. You please watch in that. Okay, so thank you. This is Shankar. I passed out MTech in IIT Kanpur and working as a faculty at Open Institute Hyderabad. If you are looking for any help in the preparation of PSU exams for assistant engineer or various boards in the various state boards, we are offering exclusive coaching for that. Both we are having different platforms like offline coaching as well as online coaching, and we are also offering the coachings for GATE, the specialization EEE and as well as the ECE. If you are interested, you can contact to the phone number given on the screen, and our website is also link is also given. Thank you. Please subscribe this video for the help of other aspirants. Thank you very much.